Now, this is our universal router plate, which we use for a number of setups at Microfence, including the ellipse jig, the interface packages, and our offensive mortising kit. You'll be able to distinguish the top from the bottom on the plate by the type of hole treatment that's used on them. For instance, there are counter bored holes, there are drilled and tapped holes, and there are counter sunk holes. All the counter sunk holes are on the bottom. On the top, they're counter bored. And the difference is that the counter bored holes have flat bottoms, and the counter sunk holes are chamfered to accept machine screw heads. You'll also see two sets of drilled and tapped holes, which you utilize for our offense mortising kit. The mortising kit can be used to entrap a cut between two fences, one from each side, to prevent alignment problems. Now, if you opt to drill the plate yourself, there's a few things you're going to need. There's a centering hub and pin that come with the unit to begin with. And then we recommend a very finely sharpened pencil. This is a through-hole counter sinking tool. It's non-chattering, very helpful in that process. This is a counter boring tool from W.L. Fuller, which you can buy in various diameters. This one's got a 1/2-inch boring tool fastened to a 3/16 drill, which we find is a good place to start. And this is a VIX bit that we use to center a pilot hole. It's made initially for hinge installations, but it works really well for determining where center is on any given hole. Now we can take whatever router that you want to mount on the plate and install a centering pin, which you get with the unit, in the collet. Then you put the centering hub into the counterboard hole in the middle of our router plate, and this will give you a center position. Now we want to establish the posture of the router on that plate with regard to how the handles are situated to the front and the back of the plate. If there are centerline marks on the router base, you can align them to the ones on the universal router plate and be consistent with that indicator. And once we have this located to our satisfaction, then we take the sharp pencil and draw the perimeter of the base as close to the base as possible. I usually angle the pencil down a little to make sure that I'm tight against the subbase of the router. And once we have that traced, we can mark, and I think you'll see on this base there's a ink mark, a Sharpie pen, to indicate where I want that base to be. Let's pay attention to which is the bottom side and which is the top side, and make sure that's correctly postured, or you'll wind up with a backwards hole pattern. Once everything's lined up, either with the pencil line around the outside or from a center hub, this particular subbase already has a counterbored hole for template guide bushings, so we're using that on this particular instance. We'll show you another one later where we don't have that advantage. But using the VIX bit, you can center a marking hole of where you want your holes drilled on the top side of the router's subbase. Making sure that the clamps are clear of whatever substrate you're going to be drilling on, you come down and make a mark on the black phenolic universal router plate. You don't have to go very deep, because you're just going to use it as a reference for drilling a through hole, which we'll show you here in a second. All right, they're marked. And now we want to drill a through hole all the way through the plate with the smaller pilot hole diameter of our counter boring tool. All the way through, being careful not to score the top with the counter bore yet, because we need to come in from the bottom to do the counter boring hole. Now we'll flip the plate over and we'll come back in to drill the counter bores. Come down and we'll set the depth so that the holes of whatever screws we're working are subsurface from the bottom of the plate. Very very important. You don't want any scoring coming from on the work surface of your job to occur because the heads of the screws are too shallow. Now, to clean up the top surface, which is now the bottom of the router plate, I want to make sure we always keep that in mind. I'm using this single hole countersinking tool. And the reason with a single hole, the reason that I choose this is because it provides very little chatter. Now, if you don't have one of the through hole chamfering tools, and not everybody does, whatever you use to do chamfering with will probably get you through. It's just the preference we have, because we do so many of them, is the non-shattering character of this one. I'll flip it over and do the same thing on the other side, usually with a little bit smaller chamfering tool, just enough to remove any burr or anything that would scratch the surface of your work. After an initial test fitting, you may determine that you'd like to open up the holes, the through holes in the subbase a little bit to give yourself a little bit more wiggle room for alignment to center, especially if you're working with a template guide bushing or something. But with enough play, you should be able to use a pin gauge or anything that's 1/4 inch diameter in the collet of the router and align it nicely into the router plate and then tighten the screws down. Now, the techniques we're showing you here can be utilized for any router, regardless of make or model. One of the most popular ones we work with is the Festool 1400. We get a lot of requests to drill for that. Now, they have a 5-hole pattern in their subbase, 2 on each side of the collet and then 1 off to the side, which we utilize to keep it in position when we're mounting it on our plate. In order to have it flush to the insert that's in the middle of the router, we have to keep that plastic phenolic, and it's actually a canvas phenolic, I think, in place. So with that still attached to the router, we'll come with our sharp pencil and draw the perimeter to give us a posture that it's in. Now, when you're determining the posture, you want to pay attention to those lines that are for hatch marks to see if they're the same as on both our plate and the Festool plate, and where your dust collection occurs. Now, we're going to be using that plate, since we purchased it separately just to have a ready-made template. We're going to use that and our pencil lines that we've drawn to clamp onto the router plate for the drilling process, just like we did before. Be sure you can see the pencil line evenly all the way around, just barely outside, knowing how carefully you scribed it when you traced the position of the plate. So I usually clamp in 3 places, and then we'll mark it to know exactly where those holes should be. Again, we're using the VIX bit to determine the center of each of those 4 holes. Then we drill our through holes. And once again, know that you can enlarge this initial hole later if the screws that you're using need a little bit more space around them to give you wiggle room. Once the 4 holes that we use for attachment are drilled, simply flip it over and do the counter board hole to accommodate the screw head. We usually use pan head screws in this instance so that we have a flat bottom on the screw so that we have some control over the position of the final lockdown. I think it goes without saying that when you're using a chamfer on a screw head, a traditional 82 degree, it's always going to pull that plate back to the same position. So you don't have near the control that you do with a counter board hole. I guess I should mention too that if all this looks like too much to deal with for you, we provide the service for a nominal fee and can do it for you before we ship it out. But if you'd like to save a few dollars, you can certainly do it yourself without too much difficulty. I think the required item is the drill press and then a few support tools like the counter sinks and the Vicks bit. Here we're opening up that center hole just a little bit. It was that extra amount of adjustment. Here we're showing that we're removing the 4 screws that we utilize to attach our base on, and we're going to test it to make sure that we have an alignment with the center of the position. And once again, you can use a drill bit if you wish, or even a router bit, although I find that the most accurate for us is a precision ground pin gauge, which are relatively inexpensive. You can get through any machine tool supply place. So there's the 4 screws and good to go. We'd encourage you to visit our website where we have video content that deals with all the setups that we've spoken about here. And hopefully they'll give you a leg up on all the different operations that the microfence can be used for and enjoy the versatility of the system. Visit us at microfence.com.